Hi and welcome to Intro to Trig Part 2, Day 2. I did not upload the note sheet today because I wasn't going to have enough room to do what I needed to do on the sheet because it's kind of small space, and so I'm just going to kind of do the problems with you. So for trig functions, what we have here is function notation. So for number one, we have f of x. If f of x equals cosine 2x plus sine x, find the exact value of f of pi over 2. Well, I have the steps written out on the top for you. 1, you can plug in and reduce if possible. 2, convert radians to degrees. And then 3, use your 30, 60, 90, 45, 45, 90, or your unit circle. And you can flip the order of 1 and 2. I personally think it's easiest to substitute in and then, convert to degrees after the fact. So to substitute in, I'm just going to put pi over 2 in place of x. So here my 2's cancel out. So I just have the cosine of pi plus the sine of pi over 2. Well, we said that pi was equal to 180 degrees. You could put 180 in place of pi. So this is really the cosine of 180 plus the sine of, if pi is equal to 180, 180 divided by 2 is 90. And then just use your unit circle. And this is the point 0, 1. This is the point negative 1, 0. Remember 90 and 180. So the cosine of 180, the x value at 180 is negative 1, plus the sine of 90, sine is y, so the y value at 90 is 1, so negative 1 plus 1 is equal to 0. So for number 2, we have g of x is equal to sine x. Find the numerical value of g of pi over 3. So what I'm going to do is, in place of x, I'm going to put pi over 3. And pi over 3, if pi is 180, 180 divided by 3 is 60. So this is the sine of 60 degrees. And find the sine of 60. Use your right triangle. 30, 60, so 1, 2, radical 3. Sine of 60 is opposite over hypotenuse, so it would be radical 3 over 2. Remember here, we're just using SOHCAHTOA. And then for number 3, we have f of x equals the sine of 7x over 2. And we're going to evaluate f of pi over 3. So in place of x, I'm going to put pi over 3. Which, in the last problem, we figured that pi over 3 was 60, because it's 180 divided by 3. So in place of x, I'm going to put 60. Because I think for this it's easier to convert to the degrees first, and then once you convert to degrees, it's easier to multiply this way. 2 goes into 60 30 times. So this is the sine of 210 degrees. And since I am larger than 90, I need to find my reference angle. So 210 puts me into quadrant 3. So I will do 210 minus 180, which is 30. When I'm in quadrant 3, sine is negative, so it's a negative sine of 30. Okay, and then my right triangle, I want to find the sine of 30. 30 is opposite of our hypotenuse, so it's equal to 1/2. So it's a negative 1/2. So this will be all. Remember, students, take calculus. Just as a reminder, 180 minus theta, theta minus 180, and then 360 minus theta. Just kind of review that real quick. Alright, so that was just basically a substitution using function notation. The next thing on the page is reciprocal functions. And the reciprocal of sine is the cosecant, and the cosecant will be abbreviated as CSC. So CSC theta is equal to 1 over sine theta, and the same thing can be said that sine theta is equal to 1 over CSC theta. Okay, note that the cosecant theta may be undefined, in particular when sine theta is equal to 0. So the reciprocal of cosine would be secant. So that means that cosine theta is equal to 1 over secant theta. And the reciprocal of tangent is cotangent. And tan theta then would be equal to 1 over cotan theta. So to determine the signs of the 4 quadrants, you want to flip your page over now if you haven't. We're going to need to use some common sense. If we have 1/2, my reciprocal is 2 over 1. And if you have a negative 1/2, the reciprocal is negative 2 over 1. So the same thing is going to apply here. All are still positive in quadrant 1. This will be sine. And since sine is positive in quadrant 2, that means that cosecant is positive. And since tangent is positive, 3, that means that cotangent, this must be a plus, is positive in quadrant 3. And that means that secant, alright, and so secant then is positive in quadrant 4 because cosine is positive, and those are the reciprocal functions. Right, so on your chart, and I think I have one too many lines. This is just like the other chart we did, figuring out what's positive in what quadrant. In quadrant 1, they're all positive. And quadrant 2, sine is positive, so it means cosecant's positive, secant and cotangent are negative. In quadrant 3, tangent's positive, so cotangent's positive, secant and cosecant are negative. And in quadrant 4, cosine's positive, so secant is positive, and cosecant and cotangent are negative. And just going to kind of extend here. Since tangent theta is equal to sine theta over cosine theta, that means that cotan theta is equal to cosine theta over sine theta because they're reciprocal trig functions, therefore just flip their fractions. So we need to write things in terms of sine and or cosine. And the first problem we have is cotangent theta over cosecant theta. Oops, forgot my C there. And we hardly ever use the substitution of 1 over tangent for cotangent. We use cosine over sine, especially since the directions say to write it in terms of sine and cosine. So cotangent is equal to cosine theta over sine theta. And cosecant is 1 over sine theta. So right now I have a complex fraction that I need to get rid of. In order to get rid of my complex fraction, I have to multiply by the LCD. In this case, the LCD is just sine theta. So multiply the top and bottom by sine theta. Here they cancel, here they cancel. So I'm just left with cosine theta over 1, which is just cosine theta. Okay, for number 2, we have tan theta over cosine theta. Tangent is sine theta over cosine theta. And get that back where I need it here. Cosine is just cosine theta. I still have a complex fraction, and my only denominator, because this is a cosine over 1, would be cosine. So I need to multiply top and bottom by cosine theta, because that's my LCD. Here they cancel out. Nothing cancels out down here, so I'm left with sine theta over cosine squared theta. For number 3, we have secant theta over cosecant theta. Secant was 1 over cosine theta, and cosecant is 1 over sine theta. My LCD is cosine theta sine theta, because those are both my denominators. Multiply top and bottom by cosine theta, sine theta. Here the cosines cancel out, so I'm just left with sine theta. Here the sines cancel out, so I'm just left with cosine theta. Sine theta or cosine theta is equal to tangent, but in this case, because the directions say leave it in terms of sine and cosine, we just leave it as it is. The last one is cotan theta over secant theta, or times, secant theta. So this is just a multiplication. Cotangent, we said, was cosine theta over sine theta times secant is 1 over cosine theta. Here my cosine thetas cancel each other out, so I'm just left with 1 over sine theta. Right, find the exact value. Number 1, we have the secant of pi over 2. Well, pi over 2 is 90 degrees. So the secant of 90 degrees. Well, there is no secant, cosecant, or cotangent buttons on the calculator, so we need to turn it into our reciprocal trig function, which would be 1 over the cosine of 90. And the cosine of 90 is 0. Therefore, this is undefined. Number 2 is the cosecant of 2 pi. Well, if pi is 180, then 2 pi would be 360. Again, no button on the calculator, so it's 1 over the sine of 360. Sine of 360 is 0. So again, we are undefined. Number 3 is the cotangent of 3 pi over 2. Well, 3 pi over 2 is 3 times 180, which is 540 divided by 2, which is 270. So it's the cotan of 270. Well, this would be the cosine of 270 over the sine of 270. So on the unit circle, the x value here is 0, the y value is -1, so that is equal to 0. Right, for number 4, we have the cotangent of pi over 4 times the cosecant of pi over 4. Well, pi over 4, so pi to 180 divided by 4 is 45. So the cotangent of 45 times the cosecant of 45. Right, this is the one time that I will actually use 1 over tangent because it's easier. So this would be 1 over the tangent of 45 times 1 over the sine of 45. Tangent of 45 is 1 on my 45, 45, 90. And that's the only reason I'm using 1 over tan. So this is 1 over 1 times 1 over, well, the sine of 45 is radical 2 over 2. So we will get 1 over root 2 over 2. My LCD is 2, so multiply top and bottom by 2. So I have 2 over root 2. Get rid of the radical where it doesn't belong. So I have 2 root 2 over 2. So my 2's cancel out. So I'm just left with radical 2. Sorry, this took me a little bit longer than I expected it would. I hope you're able to follow it without the worksheet being there, but I just knew that I just didn't have enough room to fit that on there.